Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Dr. Faisal Islam. He's a manager, an educator, a developer, and the author of both fiction and nonfiction books. And we're going to be chatting today about his new book, Kotlin from Scratch. It's a project-based introduction for programmers. How are you, sir?
I'm doing great, and thank you for having me.
Yeah, this is going to be interesting because I was my experience in the Java virtual machine world started in about 1996, 1997. And I was doing, early Java 1.1. There was a machine called the hot Java machine from Sun. And, we thought this was the future. And it seems like the Java virtual machine became the future of Java more interestingly than the language itself. How did you find your way to Kotlin, and did you also start in the early days in Java?
Oh, for sure. I started my programming journey in Fortran. I don't know if you're familiar with that, but because of my engineering background, engineers back then did a lot of programming in Fortran. Even nowadays, many of the computationally demanding tools are still written in Fortran. But eventually, when I was a grad student, I had to do quite a bit of work in C because that allowed me to manage memory. Back then, laptops or computers had very little memory, so you had to do everything very efficiently. And I did eventually ventured into Java, into Python, and so forth. I found out about Kotlin only in 2018, not too long ago. And I must say that Kotlin is literally the new kid in the block. If you look at all the major programming languages chronologically, the top ones like Python, Java, or JavaScript, or C++, they're all from the late 80s, early 90s, more or less 30 or so year old. Even the new ones like Go or Julia or Rust, they're about 14, 15 years old. And the first official version of Kotlin was released in 2016, I believe. So it is the newest language in this long series of, evolution of programming languages. The developers of Kotlin, when I looked into it and spent some time with Kotlin, I realized that the developers had the benefit of hindsight. And so they picked all the best pieces from Kotlin's predecessors and avoided some of the pitfalls or complaints about, languages like Java, which used to require a lot of boilerplate type coding. It was very verbose, right? So Kotlin has, I would say, the best features of all the existing programming languages. And yet it has a very clean syntax. Is very powerful. It's type safe. It handles, null pointers or null values quite elegantly. So, and it's multi-platform, right? And it runs on Java virtual machine, as you mentioned. So it has so many pluses. And to me, the biggest selling point is that it's not married to a particular programming paradigm. So you can, if you like functional programming, you can do functional programming. If you are object-oriented person, you can do pure object-oriented style, just like Java or C#, or you can mix and match, right? And the functions are first-class citizens in Kotlin. So all of those things together, and I immediately fell in love with this language.
Had you spent any other time with other languages that sit on top of the Java virtual machine? Because I know that the development lead for Kotlin borrowed greatly from Scala. And of course, you mentioned the benefit of hindsight, indeed. But how much borrowing does one do until it becomes more than just borrowing?
I'm not familiar with Scala. I know that it also runs on the JVM. But Kotlin is fully interoperable with Java. So you can actually run Java code, mix and match, or you can automatically get the Java code translated into Kotlin, which is a big plus for developers. It saves a lot of time. And you can directly import Java libraries, right? So I believe that there is no point in reinventing the wheel. So you can get productive very quickly. Obviously, the Java ecosystem is huge because it had 30 years of evolution, and Kotlin is just catching up. And it is the packages, the libraries that are available are becoming richer, more diverse over time. But it is obviously not as resourceful as Java. But you can always rely on Java, but code in Kotlin, and that's one of the benefits of the way Kotlin has been created.
Yeah, that interoperability, that multi-platform programming sharing,
Yes.
also between JVM and JavaScript, is really interesting. I think it's surprising and worth noting that even though, like the first commit to Kotlin was in 2010, the first stable release, to your point, was in 2016. It only took 3 years, less than 3 years, before Google says this is now the preferred language for Android. You want to do Android, Kotlin's the language. That's quite a rise in just 3 years. It impressed the right people.
I would think so, and that continues to be the case. I believe Kotlin's patron, like JetBrains, right? Mm-hmm. And they are the owners of IntelliJ IDEA, which is probably the most popular integrated development environment. Mm-hmm. And it comes built in with Kotlin. You don't even have to download it separately and install it or configure it. So it's how that easy it is, to get started with Kotlin. And they are trying to stay on top of things as far as Android development is concerned. And one of the limitations initially was a lack of a good framework for developing user interface, the front end part of any web application or mobile, or desktop application. And initially, Compose Desktop was introduced as a tool for that, and now it is morphing into what they call Compose multi-platform, so that you just you write your code only once, but then you can run it on any platform you want, and it will be portable. Whether you were running your app on Windows or Linux or iOS. So that's a big plus. And as far as I know, there is no comparable tool which simplifies this technology stack for developing multi-platform app that easily. Compose multi-platform is still evolving. Is pretty good for Android development or desktop development, and there are production-ready codes for those platforms for sure. They're also trying to, I guess, fine-tune for other platforms and add more functionalities as we go. But Google's endorsement for Kotlin still remains, and I think that will continue to drive is adoption among more and more developers. I looked up some stats, just for the for information of the listeners, that about 60% of the developers, professional developers who work on Android type, Android-based apps, they use Kotlin. And so we are talking about literally thousands and thousands of developers here. I saw somewhere that Kotlin has been downloaded for more than 200,000 times since its official release. And obviously that number is steadily increasing. So it is, even though it's the newest language, it has certainly found its footing.
Hey friends, for the next couple of episodes, as I learn more about AI, I'm going to take a moment in the middle of the show and chat with Leendert van Doorn from Qualcomm. I thought that Qualcomm was putting special herbs and spices and making things in the silicon that are secret, but all the great work that you're doing is in open source software. How do you balance being an IP company and doing so much open source?
Oh, that's a great question. Open source is a necessity nowadays, right? If you look at all these new businesses that were going in XR, PC, auto, IoT, right? Open source is the name of the game there. And so we have to participate. That doesn't mean that we're giving up all our secrets, right? There is still a lot of secret sauce in how we implement things. But how you use it, right? How developers can use it, that all needs to be open. Because again, developers are the ones that make our platform valuable. So we want to have them, we want to give them every opportunity to use our platform and to enable for it.
Yeah. And y'all at Qualcomm are starting to show up in all of the spaces that developers are. I see you in GitHub issues. I see you in the Discords. They're out there, the engineers from Qualcomm, helping enable these new tools on your SoCs. It's so amazing.
Exactly. Participation is so important.
You can learn more about all the great stuff that's happening at qualcomm.com/developers. I want to turn to your book because you point out that, it's become the place that Android developers code. It's most Android developers, the plurality of them or majority of them are using Kotlin. It's a young language, but it's become wildly successful. You have written a near 400-page book on Kotlin, but the word Android only appears in your book maybe 7 times. And I think that what I like about your book, Kotlin from Scratch, is that you didn't go in and say, here's a language you can use to make Android apps. It's very professorial because you're saying, here is a legitimate programming language, and I want to talk to you about solving interesting math and science problems with code. 400 pages, you mention Android a half dozen times. Was that a conscious decision? Because you could have just said, hello world in Kotlin is an Android application, and you did not do that.
Yes, I have to perhaps go back to the notion of how I came up with the idea, of writing this book. Originally, I was, should I say, impregnated with the idea of writing a book about problem solving. That was my original intention, perhaps on, say, computational thinking, because throughout my career, being an engineer, I used coding to solve real-world problems. And I've learned a lot, and I wanted to share some of my experiences. And programming to me is a tool, like a programming language is a tool. And if you are working on the frontiers of knowledge, sometimes you have to develop your own tool because, you're the first one to code something and see how it works. So I was decided to write that book, and I was thinking about which language to choose. I was thinking about Python because that's easy to use and it's quite universal and so on and so forth. It has a rich library. And then as I mentioned before, I came to learn about Kotlin, and I thought, wow, wouldn't it be nice to actually use this brand new language and show that in addition to developing Android apps, it has so many great features. Those can be used by anyone, beyond the professional developers or computer science students. There is a large group of individuals who do coding for other reasons, right? Academic reason, for research. And I belong to that group primarily. I'm not a professional developer. And I wanted to convey this message to them that if you're thinking about learning a new language, why not start with Kotlin? And it will give you all the features you need. Your learning curve will be actually probably much more friendlier than learning C++ or learning, a fully object-oriented language. And you have all the features you need. You can do data visualization. You can do, data analysis. You can do machine learning, all of that. Some of those libraries are being ported to Kotlin nowadays. So that was the reason to combine the two. And I clarify this in the introductory section of my book, that this is not a textbook on Kotlin. It's not a reference manual. It's not also a textbook on, say, modeling and simulation. But it is essentially about how to solve problems systematically using coding as a tool. And that was my focus. And I chose Kotlin because it's such an exciting new language.
That's really well said. Was it challenging to find that voice? Because like you know what it's not, and you know what you didn't want to do. But there is also, there's the part two. It goes directly into mathematics. It does have an academic bent, but it doesn't feel inaccessible. I would recommend this to a beginner. I wouldn't feel that this is a 400 level book. That must have been hard to find that balance as an academic and a professional.
Definitely. I mean, I tried to, because of my educational background, I tried to demystify some of the concepts that are introduced in this book. If you go beyond the section on math and science, there is a section on recursion, searching, and sorting, which is kind of mainstream computer science type topic, but it also deals with exciting topics such as fractals. And then I, go into optimization, heuristics, and all of that. But I have tried to do that without using advanced mathematics. I mentioned it that you only need high school level math, you don't need calculus. I explain the concepts, or at least have tried to explain the concepts in plain language and visually when applicable. But the important part is that when you solve a problem, a real problem, not a fictitious problem, you can see how the algorithm works, and that helps with understanding and learning way better than just solving a made-up problem, for example. So that has been my approach. It was challenging because, my publisher, No Starch Press, they tout their books as providing the finest in geek entertainment. So the books have to be entertaining or intriguing, or has to have an appeal to curious minds. So that aspect, I believe, I have been able to incorporate by, adopting this project-based approach. So once you have read the first 2 or 3 chapters that talk about the core features of the language, and the examples are still fairly realistic, beyond that, you can read the book in any order you want because they are fairly independent, even though the complexity gradually increases as you go through the chapters.
Yeah, I appreciate that. You can bounce around between the 4 major parts, and there's 9 chapters. But it did feel appropriately linear to me, and I appreciated that you very quickly got into visualizations, because I am finding with the new generation and with early in career and younger developers, being entertained at the command line only lasts so long. So being able to paint something, all right, quickly, let's visualize with JavaFX and let's start drawing fractals. Becomes very fun. I also thought it was worth pointing out that there's so many books where there's a bit of prose and then 3 pages of code. It seems like you consciously tried to make the code digestible in chunks so that I never felt like I was looking at more than a half page, where in other books you'll find that you'll be going through 2 or 3 pages and I'm expected to simply absorb or ingest 2-3 pages of code. Were you consciously delivering chunks of code as a way of being more inclusive to your audience?
Absolutely. And it goes back to my original intention of introducing the idea of computational thinking, where you're trying to solve a problem, not just coding for the sake of coding, right? So how do you solve a problem? First of all, you have to define the problem very precisely. Sometimes you try to solve the wrong problem, or you jump too fast and then realize, no, this is not really what I was supposed to do, to find the boundaries. But then break it down, decompose the problem into smaller chunks, into sub-problems, and then think about how to solve each of the small pieces and then put them back together to solve the bigger problem, right? So this is how I discuss the code. I actually solve the problem by breaking it down into smaller chunks, and then I discuss the corresponding code segment. And then you see the whole picture, then you see the output and the visualization.
Yeah. That's really cool. And then is it because of your academic background, in fact, you are a doctor, you're a PhD, that I appreciate books that have resources and footnotes at the end? And you provided even more books that I can go and read. Like I'm looking at some resources and I recognize names of people like Charles Petzold. You called out his book Code, which is just a wonderful, wonderful example. Is that because as an academic, you're taught to always include those resources and those footnotes?
I don't know if that's because of my academic background. Obviously, I'm not writing, journal articles, which I did when I was a full-time academic. But I try to provide references that are of historic importance or that are well recognized, within a certain context. So if you're going into coding, then you need to, at some point, think about what does it mean to, write clean code, and what are some of the do's and don'ts, and if you want to be a professional coder at some point, you have to think about design patterns. You have to think about, data structures and algorithms. So I try to include selectively, I'm very selective, but, include some references that I think will be helpful as further reading if someone wanted to dive deeper.
One other thing I wanted to give you a compliment about, because I've read a million books that are computer books, and they all go about this differently. But I think maybe this is a no starch thing, or maybe this is a Dr. Islam thing, but you would do little circles with a number that are basically references within a page itself, where you would label arbitrarily a for loop or a function or the beginning of another round within a for loop, and then refer to it. And it made it's a way of reading linearly, but thinking non-linearly that I found to be very innovative. And I'm curious if that's a you thing or where you found that, and if you could talk about that a little bit.
This credit goes to No Starch. I think this is the convention they use, which is quite helpful, reader friendly, I would say. I mean, I do own quite a few of their books that I read previously before actually submitting my own proposal, but I am fond of their books. And when I had the proposal ready, they're the only publisher I approached, and they accepted my proposal. But there are various ways of doing it. Like there are books where you would see line numbers, right, on the left-hand side, and then you can refer to line numbers if you want to explain something. But this way it is easier, but it's difficult when you type the book, though, right? You have to actually use certain macros to insert those circles in your text. So it's a bit laborious for a writer because at some point you have to use the template, but for the reader it helps.
Yeah. Well, I appreciate that you acknowledge that it is laborious and it caused you no small amount of pain, but I hope by mentioning it to you that you note that like it is appreciated, it is noticed, and it makes for a more fluent book, and it made the book very digestible and easier to make one's way through. Where do you see Kotlin going in the academic space? You've done work in C and Java and Python. You have discovered, it sounds like from your tone of voice, that Kotlin's now your favorite. You found the language that is your language. Are you going to stick with it and continue to kind of spread the word about Kotlin as a language to everyone?
I certainly hope so, and it partly depends. And it's not about me adopting Kotlin or continuing to use it, but how successful Kotlin will be among the being adopted by the academic research community. It partly depends on one or a couple of factors. First, Kotlin needs to have its own visualization tool. Like if, in Python you have matplotlib, in Java you have JavaFX or other third-party tools. Kotlin is compatible with Java, and that's why I use JavaFX as a mature tool, and it allowed me to do everything. But JavaFX is not necessarily the state of the art in terms of the visual style, for example, right? Some of its features may look a bit dated, and if you I also tried Julia, for example, which has great integration with some of the visual tools, visual libraries. So someone needs to make sure that similar features are available in Kotlin. I know that Kotlin multi-platform or Compose multi-platform, they have tools for web applications, which can be used for graphics as well. I haven't tried that, so I don't know exactly how ready they are. So that's one thing. And the other thing is, currently there is a lot of, whether you call it hype or interest in artificial intelligence and machine learning. And Kotlin needs to make it easy for researchers to do large-scale data mining and data analysis and machine learning type experimentation. I understand they have ported TensorFlow, for example, for Kotlin, but there are lots of other tools that are available in Java or in Python. So that is to be seen. But if you're just a casual programmer and want to play with, your own little, experimental problems or just your own little research project, Kotlin has more than enough features already. So that shouldn't be a concern. Yeah. And you will not feel constrained by the limitations of a strictly object-oriented language, or even Python, which is very easy to learn, but could be very error-prone in some cases because it's dynamically typed and so on. So I see a great potential. Whether it will materialize or not, I don't know. But I am continuing to answer the other part of your question. I have the intention to continue to write about Kotlin, and I am contributing like articles on medium.com on Kotlin and application of Kotlin and JavaFX and solving other problems. I have the intention to actually solve some of the exercise or practice problems from the book. And there are 37 projects. Each of those have a corresponding exercise, and then there are other independent exercises. So if I solve them all, it will be another 400 pages. So I cannot obviously add a solution at the end of the book, but some of the solutions will be available on Medium going forward. So that way I will continue to showcase the potential of this language, or the beauty of this language.
Yeah, that will be very fun to continue to follow that and also build a community around your book.
Yes.
And it is worth pointing out and hitting that point again that you've got 37 projects that are real world projects. Project number 12, as an example, is a really fun one where you're calculating Earth's circumference. The ancients did it, which is an interesting problem, a hard problem, but, still high school math. So it's an accessible problem that's available, for anyone. Those kinds of things, the code is all there. Some of it left as an exercise to the reader, and some of it, of course, will be able to read on your Medium. So folks can find you on social media when they go, and they can pick this book up at Amazon. It's available for pre-order, both in paperback and on Kindle. And then if folks head to nostarch.com, I'm not sure how long this will last, but there is a coupon code for 25% off, coupon code pre-order that folks can check out for that the print book and get early access. Because perhaps by the time this podcast has come out, the book will be available everywhere, which is exciting. You must be very proud.
I am. I'm relieved also that this has been a project in the making for the last 2.5 years, almost. Writing a book from beginning to end is the process, and producing a book is not just writing it, but also, as you know, editing and distribution and marketing. I was not aware of that side of this industry. So next time I decide to write a book, I will definitely think twice before committing. But let's see how it goes.
Yeah. Well, they always say that if you write a computer book, you won't get rich, but you will have fun. I'm sure it comes out to about $4 an hour for the hard work that you've done over the last several years.
Yes, obviously money was not the incentive, but It was a lot of fun for me, for sure.
Yeah, and it was a lot of fun to read. Folks can check out Kotlin from Scratch, a project-based introduction for the intrepid programmer by Dr. Faisal Islam. We've been chatting with him today on this episode of Hansel Minutes, and we'll see you again next week.